you are investing into a savings account represented by this equation. Solve the equation for t. We're trying to get t by itself. Okay. But what's going to happen is we're going to first divide by a on both sides because we want that 1 plus r by itself. Okay, so this is going to give me p divided by a equals 1 plus r raised to the t power. It should be 9. Now that we're here, we're trying to get t by itself. So the way we're going to do that is we're going to do a circle of life. And so then we can write this out as log of base 1 plus r of p divided by a is equal to t. And that is it. Not too shabby. It's just got a lot of variables. Okay, so the Richter scale measures the magnitude of an earthquake to be this, where I is the intensity of the earthquake, S is the intensity of the standard earthquake. And so magnitude of a standard earthquake is 0 because M equals log of S divided by S equals log of 1, which equals 0. So all they want us to do is they want us to rewrite this equation in terms of I. Okay, so we're going to rewrite this equation in terms of I. Okay, so we want to get I by itself. Okay, so we want to get I by itself. So the way to do that is we're going to put it in exponential form. So this is going to be 10 to the m power equals I divided by S. Now we're going to get I by itself. We're going to multiply by S on both sides. And so that's going to be S times 10 raised to the m equals I. All right, so on this one, it says an earthquake measured 8.0 on the Richter scale. In the same year, another earthquake was recorded that was 6 times stronger. What was the magnitude of the earthquake of the stronger earthquake? So basically, we're talking about 2 different earthquakes, okay? The first one, is log of intensity 1 divided by S. All right, so on the second one, we have magnitude 2 of log of I sub 2 divided by S. And it says that I sub 2 is going to be equal to 6 times I sub 1. What's up, babe? S represents the standard equation or standard intensity of an earthquake. So like on that previous page, it says S is the intensity of the standard earthquake. Say again? On the right-hand side, it says I sub 2 equals 6 times I sub 1. Okay, so then what we're going to do is we're going to plug in this information. So we have M sub 2, Alexis. Golly. So we're going to have M sub 2 equals log of 6 times I sub 1 divided by S. Okay, and all we've done so far is instead of that I sub 1, we're writing 6 times I sub 1 because it said it was 6 times stronger. Okay, this is the part that I want you to actually understand. If you have division here, you can also write this out as subtraction. So we're going to have log of 6 I sub 1 minus log of S. And since we have multiplication right here, we can actually write this out as an addition problem. So we'll have log of 6 plus log of I sub 1 minus log of S. Yep, I can erase the red. Okay, so now since we have that, this I sub 1 minus log of S is going to turn into log of 6 plus, we're going to put these two pieces back together. And this, they told us, was measured by 8. So what we're going to do now is we're going to say log of 6 plus 8. And if we plug this into our calculator, we're going to get 8.778. Do understand from this is not how to solve this. What I need you to understand is that you can write this out like this. That's all I need you to get from this. I need you to know properties. Yep, so expand it, right? Yes, ma'am. That's 2 more problems. All right, so a recent earthquake measured 6.8 on the Richter scale. How many more times intense was the earthquake than an earthquake that measured 4.3 on the Richter scale? So they told us that the first one is 6.8, and that's equal to log of intensity 1 divided by the standard. M sub 2 is going to be equal to 4.3, which is going to be the log of intensity 2 divided by the standard. Okay, on this next one, we want to find the difference between the intensities. So that's going to be M sub 1 minus M sub 2. And that's going to be 6.8 minus 4.3. And we're going to set that equal to log of intensity 1 divided by S minus log of intensity 2 divided by S. And so what we're going to do here is we're going to expand this entire line. Okay, so 6.8 minus 4.3 is going to be 2.5. And when I expand all of this, this is going to give me log of intensity 1 minus log of S minus log of intensity 2 minus log of S. Okay, friends. This negative can be distributed, and what's going to end up happening is you're going to have these cancel. Okay, so this is going to cancel with this, and then we're left with log of intensity 1 divided by log of intensity 2. Yeah, I know. Is equal to 2.5. We can use exponential to help us. So we're going to start at our base, go to the outside, finish over here. That's going to be 10 to the 2.5 equals I to 1 divided by I 2. Still want I by itself, so this is going to be 316 times I sub 2 equals I sub 1. That 316 came from 10 to the 2.5 power. That would be our final answer. So on this last one, it says if one earthquake is 25 times as intense as another, how much larger as its magnitude on the Richter scale? So they told us that I sub 1 is equal to 25 times I sub 2. They told us that from this. Okay, we already know from our previous examples that we have, this is our formula. Okay, so now we're going to use M sub 1 minus M sub 2 is equal to log of I sub 1 divided by S minus log of I sub 2 divided by S. So what we're going to do here is we're going to expand this out. Okay, so this is going to be M sub 1 minus M sub 2 is equal to, and instead of this I sub 1, we're going to write this out as 25 times I sub 2. Okay, and that's given because of this. Okay, so when we write this out in expanded form, we're going to have log of 25 plus log of I sub 2 minus log of S. We're going to subtract log of I sub 2 minus log of S. When we do this, these cancel. These cancel. And so I'm left with M sub 1 minus M sub 2 is equal to log of 25. And log of 25 is going to give me roughly 1.4. So the difference between one earthquake and another is going to be about 1.4. This is what you're going to see more often. Okay, so the pH of a water-based solution is defined by this equation, where H plus is the concentration of hydrogen ions in moles per liter. A 1 liter solution has a pH of 3. How many moles of hydrogen ions are in the system? So we have a pH of 3. So we're going to plug in for pH 3. Okay, and now we want to solve for H plus. Okay, a lot of people are tripped up by that plus sign. All it is just a fancy notation. Since there's no base written here, we assume it's a 10. Oops, oh, so sorry. I'm going to divide by -1 on both sides first, because I need to get log by itself. So that's going to give me log of H plus is equal to -3. And then I'm going to start at my base, go to the outside, finish over here. So that's going to be 10 to the -3 equals H plus. And when we simplify that, that's going to give me 1/1000.